Good afternoon, everyone. Since it's 12:30, we will go ahead and get started. And if anybody else trickles in throughout the rest of the presentation, that's okay as well. So thank you all for attending. My name is Brianna Bert, and I am the project manager for our team this year. Working with me is Jose Beltran, Gabriel Figueroa, Samuel Griffin, and Emily Rodriguez. We partnered with JB Hunt's dedicated contract services business unit in order to improve their driver integration process. Our primary point of contact at JB Hunt is Senior Logistics Engineer Zach Evans and Logistics Engineer 3, Graham Nelson. And we cannot thank you guys enough for all of the help you've provided us throughout this past year. To give you a little insight into the driver integration process, that idea is where one account has an excess number of drivers. So on our title slide, the account in blue, and then another account, the account in gray, has an excess number of loads. So the current process is where an account manager calls another account manager and sees if they have any available loads for their excess drivers to take over. So doing this allows the drivers to get extra hours and for the excess loads to be delivered on time.
So, as Bree mentioned, we have been working with JB Hunt. JB Hunt is a huge company, and they provide services in 5 main areas of delivery. Final Mile, which provides home delivery options. Integrated Capacity Solutions, which provides services that are non-asset-based. Intermodal, which uses the railroad system to transport larger amount of freight. Truckload, which provides traditional long-haul one-way transportation of trailers across the country. And finally, as Bree mentioned, once again, Dedicated Contract Services, better known as DCS. So what they do is they provide a personalized experience for clients by developing solutions for their outsourcing needs. As mentioned, the area of focus for our project is inside DCS. DCS tracks the volatility in the market in order to track excess inventory, control costs, mitigate risk, and optimize efficiencies for their clients. This is all done through the use of branded trucks, consistent drivers, and deliveries. Each DCS account enters an independent contract with a specific number of needed trucks for each customer, and then DCS grants the capability of distributing drivers over a span of accounts based on the current demand. DCS is one of the biggest and most important departments inside JB Hunt, and they have over 530 clients, 9,000 trucks, and 10,000 drivers.
Can you guys hear me? I'm sorry.
Yes.
Okay. When Mr. Hunt first started the company in 1961, he had 5 tractors and 7 trailers. Since then, the company has grown to generate nearly $10 billion in revenue in 2020. We've grown in all the segments Jose mentioned on the previous slide, but our CEO wants to continue that trend and has set lofty goals for us to double that revenue to $20 billion within the decade. With all this growth comes a lot of new customers. Many of these are names that you're probably familiar with, but as you can tell, they represent a variety of industries that all have unique requirements on how they need delivered or the equipment required. JB Hunt's the largest dedicated supplier in North America, as Jose said. This density allows us to provide extra coverage to our customers when unique situations happen like COVID-19 last year. Many of these companies like Nike, Kimball, Macy's had to shut down their operations in March of last year, leaving our drivers out of work. However, many of these stores, such as 99 Cents, Aldi, Costco, Lowe's, and Home Depot, all had booming business because so many people were trying to stock up on supplies. Our dense networks allowed us to be able to move drivers between these accounts and keep many of our drivers at work during these unprecedented times. The issues that arise from this is that we have so many unique accounts that require specific equipment or unloading. As you can see from this slide, we have flatbed trailers that deliver lumber. We have drivers that have to hand unload tires. We have drivers that use forklifts to take groceries off of the trailer. We have feed trucks that deliver to farms, and many more. This is why we approached the University of Arkansas with the problem to take into account all of these variables to help us create the most efficient transportation network in North America.
So Zach mentioned a few of the things that go into planning loads for the account managers on the previous slide. So each DCS account is managed by an account manager. And to get a better insight into how the day-to-day operations of an account manager is, we interviewed account manager Billy McCrae, who works out of the Western region for a very large account in California. So he told us that account managers first start off by planning their route. So they receive any of the required stops needed to complete the load, as well as if multi-stops are required. Then they can go on to schedule the drivers. So this is where they come in and determine if there's any specific requirements that a driver needs to have in order to complete the load. So that could be hazmat requirements, which means that they are certified to deliver hazardous materials, or if they are certified to drive particular trucks, so that might be a flatbed truck, or any of the different sizes. And then once they determine if there's any specific requirements for the driver, they can then go on to execute and monitor the load. So what that looks like is that the account manager is ensuring that all the driver's needs are being met throughout their load delivery. And then they're also reporting any key performance indicators, which are different between accounts, and that can range anywhere from tracking the miles driven to the hours worked and anything related to that account. And then lastly, they monitor the equipment and fix any issues when they arise. So the account manager's main goal is to make sure that their clients' needs are being met, as well as their drivers for their account. And so the current process that account managers use to make sure that their drivers are getting hours and that their loads are being completed is what we call driver integration. So to give an idea of what this looks like, we have two accounts located. We have the dark blue account located in Nevada, and then the gray account located in Northern California. So the idea of integration is the account manager from the blue account in Nevada will call a nearby account to see if they have any excess loads for their drivers to complete, or vice versa. And so for this example, the blue account has an excess driver and the gray account has a load that needs to be delivered as well. So in order to integrate the driver from the blue account, they will send that driver over to the gray account in California, where the driver will then complete the load before returning back to their host account and completing their normal day-to-day loads that they do over there.
Yes, so after defining our system of interest, we researched different factors that could affect driver utilization. And we interviewed, as Brie mentioned before, Billy McCrae. Being one of the top account managers from the Western region, he explained that his primary concern was the inconsistent driver utilization across the different types of accounts. Primarily, the most troublesome aspect was the low driver utilization that some drivers were getting against the high driver utilization that others were obtaining. Driver utilization is a performance measure that can be calculated from different approaches. However, there are many factors involved that could affect these numbers in the trucking industry. As a team, we came up with fishbone diagrams to help us understand these factors and see which factors we could control. After speaking with McCrae and our industry contacts, we agreed that the lack of a standardized system for integrating drivers to other accounts was our key point. Being as efficient as possible with driver integration is very important for DCS, as their drivers are paid on an activity basis, meaning that the more they work, the better they get paid. To keep drivers satisfied and busy, it is then imperative to have a system in place to help account managers oversee all the drivers' needs. These fishbone diagrams help us visualize all the factors involved in the scope of our project and which factors we could control. It then all came down to integrations and how effectively account managers could perform them without a proper system to help them do this. As of right now, the communications from account manager to account manager of different portfolios or locations is limited to personal relationships, tribal knowledge from the industry that they work in, and informal requests via text messages, emails, phone calls from one manager to the other. We believe that a platform that could streamline this process and these communications to improve the visualization of loads and available drivers was our focal point. Now, Emily will talk about the approaches that we took for calculating driver utilization.
Thank you, Gabriel. So as he mentioned, throughout our project, the team really focused on analyzing daily driver utilization. And for this, we compared the number of shifts per week to the average length of each shift per week that the driver actually receives. And by looking at daily driver utilization through hours per shift and total shifts per week, it really gave the team a much better perspective at the day-to-day factors that integration affects. So starting off, hours driven per day refers to the average number of hours that an account provides for its drivers, whereas shifts driven per week refers to the average number of shifts that each individual driver receives per week. With these equations, we applied them into learning what drivers are being underutilized, so then we could then develop our tool into aiding JB Hunt account managers in deciding what drivers need integration the most. As for our daily driver utilization data, both Zach and Graham suggested that we use 11 hours for our targeted amount of daily work hours and 4.65 for our targeted shifts per week.
Yes, so using our daily driver data, we move on to calculate the first approach for driver utilization. As Emily said, it was to find the average number of hours that each driver we were getting per shift, and divide that number by the targeted 11 hours per shift. From our calculations, we found that over 70% of DCS drivers in the Western regions in 2020 were getting well below this number. This suggests that most drivers are being underutilized according to this calculation. From our histogram, you can see that even though the mode of this data is between 10 and 11 hours, there are still drivers exceeding this range, while others don't even reach the industry average. So we believe that this approach needs to be more balanced so that most drivers are within our desired range of 11 hours per shift. Next, we move on to the second approach for calculating driver utilization, which was to find the number of shifts that each driver is getting and divided by the targeted 4.65 shifts per week. From the data, we found that over 40% of drivers weren't even reaching the 4 shifts per week. From our histogram, we can see that a lot of drivers are getting well above this number, but other drivers are below this. So we believe that a balance is needed. From these two driver utilization calculations, we can conclude that there's a problem with inconsistency within DCS. There is not a balance between shifts per week and hours per shift. We suggest that account managers assign their drivers to loads that are available without considering all possibilities. We need to have a more formal approach for account managers to share drivers and to have a clear visualization of their needs. After considering our data sets for our two approaches of driver utilization, we wanted to consider all the information possible for account managers to see. We decided to divide driver utilization from account utilization. To conduct width analysis, we look into one of the top accounts in DCS in the Western region, which was a DCSM setup, and compare its yearly utilization, as you can see in square in blue, to the utilization of 10 of its drivers. From the table on the left, you can see that there are some drivers that are exceeding 100% utilization, while others stay well below this average. This table backs up the idea that outsourcing sometimes can happen due to account managers not being able to see all available drivers on time. In addition, we look into the monthly utilization of these drivers and found that some drivers do not follow the same trends as their account that they work in. From the graph to the right, we can see an underutilized driver in the yellow line, an overutilized driver in the red line, and the account average in the blue line. Even when the top driver is exceeding expectations and exceeding 100% utilization, the bottom driver does not show any signs of improvement. We can conclude from these visuals that in some accounts, the overall utilization is the top priority, while the driver utilization comes in second. We believe that a solution will then allow account managers to see the underperforming drivers and the underperforming account so that they can keep driver integration more consistent and drivers keeping the trends from their account they work with. Account managers that use this solution will potentially be able to consider driver utilization, account utilization, even location, and other load requirements when sending or receiving drivers. Now we will explain how we will introduce locations to our solution.
So as Gabriel mentioned, we looked into the individual driver utilization as well as account utilization. And so to get a better idea into some of the other factors that might impact the driver utilization, we looked into 9 of the Western region hub cities. So we split up our data in this way after talking to Dr. Chimka, because we found that with our data set that we currently had for all of the drivers within the Western region for every city, that our data set was very large and it was just giving us inconclusive results. So splitting it up by city allowed us to kind of get a better idea into if particular factors only had an effect in some cities versus the others. And so using an alpha of 0.1, we did find that the time of shift, so whether or not the driver is doing the majority of their driving during the day or at night, if they needed any hazmat requirements to deliver the loads, as well as if the driver had to unload the truck or have any particular requirements associated with that. So using those 3 factors, we found that in San Bernardino, actually all 3 of them had an impact in predicting the utilization. And then they all had some kind of impact in the other cities as well. So now Jose will go into a little bit more detail on how we can use these findings in the development of our solution.
Thanks, Bree. As mentioned, we did have a stakeholder interview with Billy McRae. He gave us a lot of really good insights into other characteristics that may affect driver utilization, besides from the ones mentioned in the previous slides. As someone that has to make the decisions of finding a driver for his load or a load that his available driver can match up with, Billy included account code, starting load location, whether the load is local or regional, the driver capacity, and whether the account in question actually needs help. So alongside those, and the ones that we got from our multiple linear regression analysis, which were the time of day or day driving or night driving, special restrictions, things like hazmat qualifications, and whether the unload has to be manual or not. These characteristics kind of began to paint the picture as to why some drivers have a lower utilization than others within the same account. So after our interview and the findings from the multiple linear regression test, we were able to put together a list of the most important and impactful characteristics that each driver and load can possess. We knew that in order to increase the driver utilization across all drivers in an account, our team needed to create a tool that would present all these details to the account manager at the time of a decision. So in order to meet our industry partners' request of increasing utilization, our team knew that we were going to be creating a tool that would be used by a DCS account manager daily. At first, we struggled producing a tool, so we decided to create an alternative generation table that you can see here. To begin the creation of this table, we needed to pick the 4 most important decision factors for our potential tool. The first is complexity, which indicates the difficulty that a tool would take to create based on the skill set of myself and my other 4 team members. Data input, which deals with how the data that a tool uses is accessed. Ease of use, which refers to the complexity of the tool, and therefore the difficulty level that the user will need to have and master in order to get every functionality possible out of the tool. And finally, as I just mentioned, functionality, which we believed was the most important decision factor, which highlights what the user can get out of the tool and the functions that it gives the user. After filling in aspects for the decision factors, 4 alternatives began to take shape. The first was an Excel VBA tool, which would use an SQL query to provide reporting in order to kind of identify bottlenecks in the current process. Next was an Access database, which would again use SQL queries, but this time build upon the reporting functionality of the Excel VBA tool and provide the user with different functions which would affect decision-making and make the process more transparent. The third was a Power BI tool, which would utilize J.B. Hunt's preferred reporting platform in order to create reporting that was easily accessible. And finally was a forecasting tool, which would have been used to forecast demand of drivers in order to provide an account manager the plan to kind of avoid the underutilization that they were seeing.
Yeah, so as Jose mentioned, our team had a lot of deliberation on what would be the best software to use for the tool. but we eventually decided on Microsoft Access. So the first few iterations of the tool were just kind of builds that had a lot of different buttons and were intentional rough drafts to try to capture all of the desired functionalities of the tool. But after weekly meetings with our industry partners from J.B. Hunt and drawing on the insights from our stakeholder interview with Billy McCrae, we eventually narrowed it down into kind of 3 major sections that the tool could take. And so pictured on the slide is a screenshot that shows kind of the main menu or the splash page that our tool shows now, and those 3 sections. So the first of which you'll see is driver information. This is essentially to provide editing capabilities to the account manager, whether it be on if that driver is available for integration or where the fleet code that driver may belong to is, things like that, things that may need to be changed as time goes on. The second section is account information, and it's mainly a reporting section, provides lots of information and metrics on account manager's own drivers or on loads nearby to them, and an attempt to give them a better idea, better visibility, better information in their decision-making process when trying to find where the integration opportunities may be. And the final section is called Locate Driver, and it's really the meat of the tool and is meant to kind of really help the account manager find where drivers might be nearby, whether that be by zip code or by fleet code. So you'll also see these kind of question marks by each title of the section, and that essentially pops up a message box to the account manager that provides little descriptions, kind of like I just did, so they don't have to click through the buttons and figure out what everything does. And you'll also see at the top left, there's a summary button, and this just pulls really a table report that shows the total available drivers by fleet and the total available loads by fleet. So now Emily will go into more detail on the first of one of these sections.
Thank you, Sam. So as Sam mentioned, driver information is the first section on our tool, and it provides the account manager with the capability of making changes to information that's more subject to change over time. So to start off, you can see where an account manager is given the option to select update availability. And once the account manager selects update availability, they will be prompted to a form where they will then be asked to select their designated fleet code from a drop-down box. And once the fleet code is selected, the account manager will have to select Find My Drivers, and then a query will run, and the account manager will be prompted a data sheet report where all their fleet drivers and designated driver information gets pulled. For this report, we did limit the fields that are displayed so that only a necessary amount of information is available to the account manager. As you can see on the slide, the information that the query pulls is located on the bottom right of the screen, and the information listed would be driver code, availability status, whether the load is hazmat, driver and load requirements, and kind of like a confirmation column with the designated fleet code so that they know that that driver is 100% in their fleet. And all the columns, excluding the availability column, are locked. That way, no other information can be changed, only the availability status. Similar update driver information works hand in hand with update availability. Once the account manager selects update driver information, they would be prompted to select their fleet code from a drop-down box again, and they would have to select Find My Drivers. The only difference here is the report that gets pulled contains more information that's subject to change over time, which could be like the fleet code in general or the driver code or any other information. And again, we did limit the information that is displayed on the report to the account manager. So it doesn't have all of the driver's information, but only the information that's more subject to change. And the cells in the report under update driver information, none of them are locked. That way they do have the capability to alter.
Yeah, so one of the major things that our tool needed to be able to use and implement was account proximity, or the distance and miles between each account. So the data we were working with was in the western region of DCS, which mainly included a high density of accounts in California, along with some other accounts scattered across the western states like Nevada or Colorado. So for the example on this slide, we can assume that we're the account manager of the circled account and that we're searching for nearby drivers. So the records that are shown in the top right are an example of what our tool could show to this account manager. So you'll see a lot of fields are pulled, and there's actually some cut off in this screenshot that are some of the extracurriculars that were mentioned, like if the driver is hazmat certified, and what percentage of time they may spend driving at night or during the day, to better give kind of the account managers a vision of who might be the best fit. But most importantly about these records, you can see the driver utilization is sorted from least to greatest, in an attempt to pull these drivers that are most in need of work or the drivers that would most benefit from integration to the top of the list for the account manager. So the tool is actually already pulling drivers that are nearby due to the design of the tables that are within the tool. So when our team first decided or first tried to implement distance, we decided on using a matrix table with all the zip codes and the rows and columns and just the distances kind of in a matrix format filled in. But we quickly found out that trying to use a table in this format and Microsoft Access is not very intuitive. So after some meetings with the faculty, we created another table that was formatted a little more intuitively for our tool and had the origin zip and the destination zip combinations under 75 miles for all the zip codes that we had in the Western region. And so by using just this table and restricting all of our queries by linking it to this kind of location table, all of our results are actually already pulling drivers that are within 75 miles of the nearby or designated zip code.
Yes, so Sam touched a lot on locating drivers and how we implemented that into our locating driver section. And because integrations currently take place by word of mouth, we felt like this function was really going to aid account managers in locating drivers instantaneously. So beginning with the zip code functionality, the account manager can select by zip, where again, they would be prompted to a form with a drop-down box where they can then select the appropriate zip code and select find drivers near me. As I mentioned, the results will then pull drivers within a 75-mile radius of the zip code. And once the query runs, the data that gets displayed would be relevant information that would aid the account manager in deciding which driver would more than likely be capable of integrating. Some of the most important fields we took into consideration, again, were utilization, hazmat, driver unload, and whether or not they are available. And one thing we considered was to make sure that the drivers, as Sam mentioned, with the least amount of utilization were displayed at the very top of the report so that they're kind of considered like top priority. And to use locating drivers by fleet, the account manager can select a fleet code from the drop-down box and select locate my drivers. And once they select locate my drivers, again, the query will run and another data sheet report will get pulled. And displayed in that report would be drivers with their fleet code, their utilization, their current location, how far they are from their origin destination, and the current like work status that they have going on.
So the final section of the tool is titled Account Information. And this is kind of intended to be a reporting resource for the account manager, mainly meant to be informational and provide some kind of better visibility so they can make better decisions and see better where the best opportunities may lie. So the top button, Account Specific Report, will direct the user to a page that shows both of the buttons and combo boxes you see on the right, the top of which will ask for a zip code. And then based on the zip code, we'll generate a report that shows all the nearby accounts and their previous year's quarterly breakdown and their total activity. So as Zach mentioned earlier, DCS has over 500 different accounts. Each is kind of their own client, their own industry, and they might have their own demand curves or seasonality. So by providing kind of this quarterly view of activity for these nearby accounts, we're hoping to give account managers a better idea of when nearby accounts may be surging or about to hit a boom or a valley in demand. So they can kind of better prepare their own drivers for integration and work. The bottom button, still from this page, asks for a fleet code and generates a report on their own drivers or on the drivers of that selected fleet. And provides just some extra metrics as well as utilization like hours per shift and shifts per week that were mentioned earlier in the presentation that proved to have a good impact on driver integration. So the bottom button, view available loads, will direct the user to a page that's very similar but mainly based on load information. So they can select their zip code and generate a report that shows all the nearby available loads to them. Or they can select a button that simply pulls all the available loads by fleet so that they can get a better idea of where the integration opportunities may lie in terms of loads.
So you know a little bit about our tool now, so we'll talk to you about the impact that our tool could have. So DCS has estimated that the implementation of our tool in the West region can provide both monetary and time savings. Our tool has the potential to reduce the need for additional drivers by up to 20, which would save an annual $2 million, considering that the sum of the wage and benefits that a driver gets is around $100,000. So assuring that account managers are also able to find available drivers for all the loads would result in an extra 6,130 extra loads kept in-house rather than outsourcing to contractors or independent drivers. The main emphasis of our project has been resolving the issue that an account manager faces when looking for an available driver. If our tool is used by all account managers in the West region, it is estimated to save 8,320 hours of time. DCS would also like to emphasize the fact that our impact analysis numbers are based solely on the Western region. So all of these numbers, as impressive as they are, can be scaled up if the tool is implemented into all regions that DCS operates in.
Yeah, so with all that being said, when our team first started the project, our goal was to improve the driver integration process across DCS accounts in the Western region. So we built and developed an access tool that uses proximity and utilization to locate these available drivers while also providing the account managers the ability to update information in one place. And DCS estimates that the implementation of our tool in the Western region could potentially save $2 million in driver wages and over 8,000 hours of work for account managers and 6,000 extra loads. So I wanted to give another special thank you to Zach Evans and Graham Nelson again for all the help and guidance they provided us throughout the project, as well as to Dr. Cassidy and Dr. Schubert and Macy Tush for their help on the Arkansas engineering side. And I want to thank everyone for coming today to hear a little bit about our projects and our presentation. We've all worked really hard and we're really proud of what we did. So with that concludes our presentation. And I think we can open the floor up for any questions.